Hello. Hope you all are doing well. And we're going to wait about a minute or so, see if anyone else joins us to watch live. But just a reminder, we're doing day 3 today, which is on double box plots. So hope everyone, their packet 3 is going well so far for all classes, and hope you're having a good week. Hope you got to enjoy some of the nice weather that we have as well. As we're waiting on a couple of people, just a little shout out to my sister Kara. It's her birthday today. She's 25, so happy birthday, Kara. Hope she has a great day. So if you, once again, just a reminder, as we go throughout the live stream today, if you have any questions as I'm talking about anything, go ahead and type them into the chat and I should be able to see them and answer them. And then if you have any questions later on as you're working on any of the packets and the practice questions, send me an email or a message and I will be sure to get those answered for you. Hopefully the one that I did on Tuesday for days 1 and 2 helped. And so we're going to do that today. We'll go ahead and get started. Make sure, once again, you got your packet. If you have it with you, turn to day 3. That's what we're going to be looking at today on double box plots. So a double box plot, hopefully you have seen a box and whisker plot before, because that is what a double box plot has to do with. So a box and whisker plot looks like this. Before we talk about all the ins and outs of this double box plot, what this is it shows you kind of a collection of where most of the numbers in this data set are. So think about on Monday, Tuesday, Wednesday, we have a list of numbers in the data set. We're not listing all of them out, but what we're saying is the smallest number is 0, the largest number is 30, and then most of the numbers fall in between where this box is at. And this box is in between 5 and 20. So most of the numbers in this data set fall in between 5 and 20. The smallest is 0, the largest is 30. If we're looking at science class is underneath, same thing. The smallest number is 0, the largest number is 30. In this case, most of their numbers fall in between 15 and 25. So that's what a box and whisker plot does. And so the way that what we're going to be looking at in this lesson, we're going to be using the box and whisker plot to kind of see what data set is bigger, which one has bigger numbers, which one is more spread out. So first of all, I've labeled the different parts of the whisker plot because I want you to understand what each is talking about. So we've got the smallest number is that dot at the very end at 0. The largest number is the dot over here at 30. And then the box, that's where, like I said, most of the data is centered at, is collected at. And we call the smaller line, so this one is at 5, is called Q1. Q3 is the other end of the box, the larger end of the box. And then the middle line, this is the really important thing, the middle line in your box, that is the median. We don't care about the mean, we don't care about the mode in a double box plot. We only care about the median. They give the median to you. In this case, in math class, it's 10. Science class, it's 20. Okay, so Q1 and Q3, what's the purpose of that? The purpose of that is to find what's called the IQR, or the interquartile range. IQR is what it's going to be called a lot. What the IQR does, this tells us how spread out the data is. Are all the numbers really close together, or are they more spread out? The number that you get is just going to be one number that you get whenever you find the IQR. If it's a bigger number, that means they're more spread out. If it's a smaller number, that means they're closer together. The way that you find the number for the IQR is you take Q3 and you subtract Q1 from it. Q3 minus Q1. So if you notice, you look at this box and whisker plot, You've got Q1 already. You just have to come down and say it's at 15 for science class. You have Q3. It's at 25 for science class as well. So you just take 25 minus 15. Your IQR would be 10. We're going to look at that. This is the box plot from example 1. So we're going to look at that here in a second. But the IQR is one number. The median is one number. The median is given to you with that middle line in the box. The IQR, you just take the two ends of the box, subtract them, and that's going to tell you how spread out your data is. Okay, so just a few more things when talking about double box plots that I've got here. The box plot with the bigger IQR has data that is more spread out. So the box plot that's got the IQR of a bigger number, data is more spread out. Second thing, the longer the box is, the more spread out the data is. So if you notice up here in math class, you see the box is longer than the box in science class. That means the math class numbers are more spread out. The science class numbers are all closer together. And so if you just look at the box, that's going to tell you which one is more spread out. So the wider, the longer the box is, the more spread out it's going to be. And then the last point here, the median will always be the average. So remember on Tuesday when we talked about mean, median, and mode. We said sometimes it's better to use the mean, sometimes it's better to use the median, sometimes it's better to use the mode. We will always use the median when we are talking about double box plots. So like I said earlier, we don't find the mean, we don't find the mode, we just care about the median, and that is going to be that middle line in your box. So the median will always be the average or measure of center that you use for double box plots. Okay, so that is kind of the information that you need. I'll try and keep this right here, and we're going to need to look at this double box plot as we look at example 1. So if you have your packets, go ahead and look at that first example. So the first example is talking about math class and science class. So these are the exact double box plots that you need to be looking at. And so the question says, first of all, what is the measure of center for each class? Remember, the measure of center, we said, is always going to be the median. Okay, so we are going to just find the median, and this isn't too bad because the median for math class, find the line, come down, it's at 10. So the median for math class is 10. For science class, the median is that middle line in the box, drop down, it is at 20. So the median for math is 10, the median for science is 20. The next question is, what is the IQR for each class? Remember, IQR, you take Q3 and subtract Q1. So for math class, you're going to take Q3, which is at 20, and subtract Q1, which is 5. 20 minus 5. For science class, you take Q3, which is 25, subtract Q1, which is 15. 25 minus 15. So putting all of that together, for math class, the median is 10, and the IQR, Q3 minus Q1, should give you 15. For science class, the median was 20. The IQR, 25 minus 15, is 10. And so that's all that you have to do. You don't have to say anything else. So if they were to ask us questions later, like which class has more blog posts each month, we would say science, because science class is closer to 20, and you notice most of their data is right around that 20 spot. If it says which one is more spread out, we would say math class is more spread out, because 15, the IQR, is bigger than 10. So that's how you can interpret the median and the IQR when talking about double box plots. So that's example 1. Example 2 gives you this box plot right here talking about the speeds on different roads. We've got Hayes Road, we've got Jefferson Road. So this is the double box plot. You should be able to see it on your packet as well. The first question is, what is the median and IQR for both? So the median for Hayes Road, if you look up here, the middle line, drop down, that is at 55. Okay, the median for Jefferson Road, Jefferson is right here, the middle line in that box, you drop down, and that is at 45. Okay, so 55 for Hayes Road, 45 for Jefferson Road. What's the IQR? So the IQR for Hayes, you take Q3 minus Q1. Well, Q3 for Hayes Road is 60, Q1 is 50. So you see 60 right here, 50 right there. 60 minus 50 gets us 10. Okay. For Jefferson Road, okay, the IQR, Q3 minus Q1. Well, Q3 is 55, Q1 is 40, 55 minus 40 is 15. So if you notice, Hayes Road, the median is 55, and they're all really close to 55. Everything's farther up on Hayes Road than it is on Jefferson Road. So that leads us to the second question that's asked, and that is, on which road are the speeds greater? Well, you would say the speeds are greater on Hayes Road. The reason why it's Hayes is because Hayes, first of all, the median, the average, is higher than Jefferson Road. And notice that all the numbers on Hayes Road are farther up on the number line than they are on Jefferson. So all of them are really close to, I think 55, yeah, 55. And so you're going to say Hayes Road, the speeds are greater. So that's all that you need to know for this. One other thing I want to show you, if you're looking at this double box plot, you see that one dot right about 77 or 78 for Jefferson. Okay, so that dot or that little star, think back to Tuesday. Remember we talked about outliers or extreme values? Remember we said that outliers are numbers that are far away from everything else in the data set? If you see a star or something like this at the very edge of a box plot, that is the outlier. We do not really care about this outlier when we're talking about the median or the IQR. Okay, so we see this outlier here, this star. It's by itself, it's way far away. We don't really care about it. Okay, that does not factor into anything that we're doing. And so don't let this confuse you when talking about Jefferson Road. That means that one car was going really, really fast, 77, 78 miles per hour, but we don't care about that. We just care about what is here in Jefferson Road with the box and the median, the IQR. Okay, so just to recap, the median is the middle line in your box. The IQR, you take the numbers at both ends of your box, Q3 and Q1, and you subtract them to get one number. The bigger the number in the IQR, the more spread out your data is, the more spread out the numbers are. And then to figure out which road has cars that go faster, we just compare the medians, and we see this one's more higher than, on Hayes Road is higher than Jefferson, and everything's really close to 55. So we would say Hayes Road has the higher average speeds. Okay. So once again, as you're working on your practice problems for days 3 and 4 double box plots, if you have any questions, be sure to let me know. Hopefully this helped, and hopefully everything goes smooth for you. I guess I'll end with something that I would end with if we were in the classroom, which is a corny dad joke. I saw one that I had to share with you guys. Why was the broom late for school? Because he overswept. All right, I figure that's a good way to end it. Hope you guys are doing well. Hope this helped you all. Let me know if you have any questions. And I will see you again 11 a.m. on Monday, May 4th. We will look at day 5 and 6, which is double dot plots. Okay. Hope you guys have a good rest of your week.